Okay, so basically today we have to discuss the concept of projectile motion, and projectile motion is completely like a very new concept. In our daily life, we already discussed some examples, some basic background of the projectile motion in the last class, that we have to consider a semicircular motion or a quarter circular motion, just like if you throw something from the second floor of the building, so that will move for a very short time in a straight line, and then it will make a curve till the ground. And let's suppose if we take the example of the football, if we kick football uh, from the wall of the player, so that is also a projectile motion. We started from the ground and we ended up till the ground, so that is complete a projectile motion, right? So we need to
Yeah.
discuss the things about or the motion like this, the example of the old machine catapult. So that will also work on the same principle, because we need to know about the range and the equations that we need to apply, because we uh, let's suppose if we want to know about some specific range, that if we throw something from some point, so at what angle or at what speed we just reach the point or our destination. So that is the whole thing that we need to discuss in this chapter. And this is also a very interesting type of the motion, because this is something new from the previous concept, because till now we are only talking about backward, forward, up and down motion. So this is something different. So today we have to discuss projectile motion. Okay, so again, first of all, main important thing, what is projectile motion, right? Because we know the projectile motion, but it is always compulsory to explain the concept in scientific form. So basically, one important thing in the projectile motion is, let's suppose if you just kick the football from the ground and you are going to just move that ball over the top of the wall of the players into the net or into the goal. So basically, that is also a type of projectile motion. But the most important thing is, let's suppose if we just kick that ball, so basically when ball only moves in if we consider only horizontal direction, right? If we just consider straight forward direction, we are not talking about the vertical direction, because now we need to apply the concept of the components of forces, because in this concept we have two different components. One is the horizontal, second one is the vertical. Because we know velocity is a vector quantity, so we need to discuss with the concept of the components, right? So if we only consider the horizontal direction, so speed in horizontal direction, or we can say that the horizontal component of the velocity remains the same, because we try to kick the football into the forward direction, right, with some height. Okay, and you know that height will continuously changing, because we started from the ground and we reached the ground, but at some horizontal distance, right? So basically your horizontal distance is permanently changed, but your vertical distance is started from zero, then it reached the maximum point, then again it comes towards the zero, right? So basically if we want to write the definition, so your definition is um like this, we can say that you got the concept of the component when we draw the components and discuss the concept. So first of all, we can say that the trajectory of an object undergoing projectile motion consists of a vertical and a horizontal component. And for projectile motion, you may also write like this: the motion in which the horizontal component of the velocity remains constant throughout the motion, because that is the very important thing. So because we know that if we are working with the projectile motion, so there is one assumption in projectile motion, that your horizontal component always remains the same. So you can also define projectile motion like this: the horizontal component of a velocity remains constant. So now you got one concept, that there are two components in this motion. So we always need to discuss about the two components. So according to the situation, let's suppose if we first draw a projectile motion. So this is our x and y axis. And if we want to draw a projectile motion, so let's suppose, okay, so we just consider motion like this. Okay, so this is our projectile motion, let's suppose. And we are talking about the components. So let's find out the component. Let's suppose if we start from this point. So basically our uh, in our motion, or during when we are trying to kick that football or that ball, so our main purpose is to just skip that wall and just try to move that ball into the net. So basically our main direction or our main purpose is to make the ball move in this direction, right? Because when we try to kick the ball, so we always consider one direction, right? But due to gravitational strength or due to gravitational force, ball will ultimately move in downward direction also, right? So that's why our main focus is in the direction of that red line. So let's suppose if we consider this one as velocity u. Okay, the initial velocity, because initially we kick the ball with some velocity, then the projectile motion begins. And at the half point of the motion, like this, so at the halfway we know that this is the maximum point. Then after this point, ball is going to move in downward direction, right? So half part is in the upward direction and rest of the part is for the downward motion. Clear?
Okay, got it.
And if we make components, right? So this will be your x component, x component of initial velocity, that is ux.
So it's like the angle.
Yes,
So like for you, it's gonna be like 45 degrees.
yes. So angle, maybe it might be any angle we choose, but we are just only talking about components right now. We also discuss about the angle, that at which angle we got maximum distance from one point to the other point, and this component is uy. Okay.
Okay.
And if you remember from the concept of the resultant forces, that if we want to solve the x component, so your ux is equals to velocity with cos theta, and y will be equals to sine theta. If you don't know the concept, so let me know. I will explain it again why we are using cos theta with x and why we are using sine theta with y.
Can you explain one more time?
Okay, so basically, let's suppose if we consider this horizontal condition, like the horizontal motion when forces are acting in two different directions. So you know the concept of resultant, right? If two
Yeah.
forces acting in two different direction simultaneously, so body will move in the diagonal form.
Mm-hmm. I get that point. So it's
Yes,
gonna go like you're gonna make like the parallelogram and then you're gonna
yes, yes. Or
put
you
the
just
line
take the
in each
reference from the right angle triangle. Sine theta is
other.
equals to perpendicular upon hypotenuse and cos theta is equals to base
Up.
upon hypotenuse, right?
Oh yes.
So let's suppose if this is the resultant force, so we make a y component over here. Let's suppose this is uy, this is ux, this is angle, this is 90 degree. So if we want to solve for ux, let's suppose if we need to find out the value of ux, so we use the trigonometric identity cos theta, because cos theta is equals to,
So if you want to find out what the base is, like what the
yes, the
base is, you're gonna
component.
do the hypotenuse.
Yes,
Uh,
because we are not going to take the vertical component because vertical component is different. So we consider hypotenuse and the base. So we need to choose these two parameters, and these two parameters are only available in cos theta, right?
okay, I get it.
Yes.
Clear.
And same goes with the vertical component. Some people have P over H. So this will make, if we cross multiply, so ui will be equals to u sine theta, ux will be equals to u cos theta, right? So in this way, we just make the components, and we are also making some angle with the ground. So that is a very basic concept related to the projectile motion that we need to discuss. And we also got the concept that half of the motion will be in upward direction, rest of the motion will be in downward direction. So that is the situation, right?
Okay.
And the next thing we need to discuss is, or we can say that what things we are going to discuss in this chapter or in this concept. So we need to discuss the time of flight. It means the time period, right? During the projectile motion. Next, we need to discuss maximum height, how to find the maximum height reached by the body. Because these things are very much important while projecting a satellite from the Earth's surface into the space, right? So this projectile motion and centripetal concept combines and gives you the final value that at which speed and at which angle we have to just launch that satellite from the Earth's surface or any rocket from the ground surface into the space, right? Otherwise, it will happen like that rocket launches and it will just land on the Earth again on some other side. So that is very important. And the third thing is range. So there are specific equations and a specific procedure to follow for each component. Let's suppose if we start from the time of flight. Okay, basically in time of flight, again, we know that there are two components. So let's suppose if we start the concept. So time by time, you got all the things. So first of all, we are talking about time of flight. So let's suppose for the time of flight, we are starting with vertical motion, or we can say that we are taking vertical component. So we are going to discuss about the vertical component first, then we will discuss about the horizontal component, right? So for the vertical component, because some quantities can be derived from vertical and some quantities can be derived from the horizontal component, right? Because if you just calculate the time for upward motion, so it will be same for downward. So you just add them and you will get the total time. Okay. So the components that we required for the time of flight is we need to take u y is equals to u sine theta. It means the y component of the speed. And what will be the final speed? Because you know what, whenever we reach the maximum height, so your final speed will be equals to zero. Just like we throw a ball in upward direction, at reaching the maximum height, final velocity will be equals to zero. So we are going to take the same reference, that why we divide the whole motion into two parts. So at initial we are having speed u sine theta, and for final speed we are having v is equals to zero, right? And again the same concept, we are moving against the gravity, so g will be negative, and we need to find out the time. So once you got all the components, so then it will be easy for you to find choose the equation, that which equation will help you to find out the answer. So initial velocity will be equals to u sine theta. Final velocity will be equals to zero. Acceleration will be minus g, because we are moving against the gravity. Time will be unknown, right? So try to figure out which equation helps you to find out the final answer. Think about the equation if you want, so I will show that all equation again.
No, I got it.
Okay, so which equation help us to find out?
To find out time.
Yes, we need to find out the time.
Um, wait, I did this the other day.
Okay, no issue. So basically, let's suppose if I write the equation, so you may easily identify that this equation will help us.
U plus AT, right? The V
The
equals
first
U
one.
plus
Yes.
AT.
So basically, we need to use the first equation. V is equals to u plus at. So good. You need to use the first equation. So this is our equation, and from this we can easily find out the value of time. So just quickly plug in all the values. So you will be 0 equals to u sine theta plus minus g into t. And this minus gt will be shifted on the left hand side, so it will be positive, right?
Okay.
And finally, you will get your value u sine theta over g. Okay. But
Okay.
this is only for the upward direction, right? This is only for upward direction. This is for the upward motion. Why upward motion? Because we take this point, the maximum. So this is half motion. As I already mentioned that if we calculate the half time or the time for the maximum height, so rest of the motion will be the same copy paste with the same time, right? Okay.
Okay.
So what we need to do? We just need to multiply this value by 2 or just add again this value for the total time. So before that, if I write one important point, so that will help you to remember after the class. If t is the time for or time to reach maximum height, then total time for flight will be 2 times t, right? Half vertical upward motion and half downward motion. Combine them, you will get the total time. Okay, very simple. So your answer will be multiply just 2 on both sides. Okay. So basically, we may write this 2t into capital T. So let's suppose this capital T gives you the concept of total time. Okay. So we just replace this 2t with capital T. So this is the formula for the time to flight, right? Any confusion?
Nope.
Okay. So because if just I write 2t, so that will always confuse you. That if we are writing 2 on left, 2 on right, so that will easily cancel out each other. So we are getting the same answer. So why we are writing 2 on the both sides? So that's why you need to just replace with capital T. So capital T or any other symbol for total time.
Okay.
Right. So the next thing that we need to discuss is maximum height, right? We discuss about the time to flight, and now we need to discuss about the maximum height. And this derivation is also important because sometimes they ask about drive the relation or drive the expression for the time to flight for projectile motion. So next concept is related to maximum height. And you again know that for maximum height, it is compulsory to take the vertical component, right?
Okay.
So if we consider again the vertical
Oh,
component,
we're gonna use like the second one, the v square equals u square.
yes, okay. These two things remains the same.
Okay.
Only t is replaced by h. So t is no more important. So you are right that we need to use the second equation that only contains distance and velocity because time is no more important for us. So we can say that 2as v square minus u square. So we are going to use this equation. So according to this, 2 minus g, s is going to replace by total height h, final is 0, initial is u sine theta whole square, right? And you know, again, no, there are minus sign on both sides, so both will cancel out each other. So you will get the answer. H is equals to u square sine square theta over g, 2g, right?
Okay.
So this is
So
the
then,
formula for maximum
so
height.
this is like, okay, got it. And then is there anything else? The range,
Uh,
right?
yes, the third one range because we know maximum height only consists half part of the motion for the
Mhm.
maximum, and the third one is related to the range. Now in this component, in this section, we have to choose horizontal component. right? And one more important thing, because you know that during the range or during the horizontal motion, you know that there is also a force of air resistance, right? That will cause friction in the air. So we are taking air resistance negligible, right? Because if we include the air resistance, so your case will be very much complicated, right? You need to just find out the resultant force, then take at each single point we need to find out the direction, because in circular motion direction will always change at each and every point on the circle. So that's why one more important thing is that during the range, because the value of g you already understood, that why we take negative and why we take positive. So one more assumption that we made in the projectile motion, this is only the assumption, right? We are not going with the same assumption for the practical concept, because for the time being we are just thinking about the basic concepts, right? Then we will move on the advanced concepts, right? So for the time being, at this particular level, we are taking air resistance negligible, right? Because you know in the football game ball also curls, that is also like from one point to another on the ground, but the direction is changing in third axis, right? So if you consider the air resistance, so that is very much complicated to solve this equation. But let's suppose if we consider roughly, because normally we throw object with a very high speed, so we try to add extra force to overcome the resistive force, right? Because we can easily calculate the force from the air molecules also. So that's why for the time being we are taking air resistance negligible, right? And now we are taking horizontal component. So initial velocity this time equals to cos theta, and acceleration, what will be the acceleration? Because one more thing that we discuss, that horizontal component of a velocity remains constant. So if your horizontal component remains the same, so what will be your acceleration this time? Is it going to be a same variable or something else?
Is it going to be something else?
Okay, let's suppose if your speed or velocity remains constant, so what will be your acceleration in simple form? If your speed or velocity is constant in
Yeah.
horizontal or linear motion, so your acceleration will be equals to, or
Um,
if you are
it's
moving with constant speed, let's suppose if you are moving with constant speed, so what will be the value of acceleration?
it's going to be 0.
Yes. So we are going to use the same concept, because in the initial stage of projectile motion, we already discussed that your velocity remains same. That is the horizontal only, not the vertical. Okay.
Okay.
Okay. So we were talking about the horizontal component of the velocity. So when horizontal component remains the same, so your acceleration will be equals to 0. So we need to apply the same knowledge on the derivative part.
Okay.
So your acceleration this time equals to 0. And I think this motion is very much easy as compared to the linear motion right now, because things are very straightforward, but don't know in the numerical question might be you find it difficult. And we have to find out the range. Range means
Oh,
horizontal distance. Previously we find vertical. This time we need to find out the horizontal. And one more thing, you may take the plus point of taking the time, because we already have a value of total time. So that is a plus point. So I'm going to write the total time.
okay.
So this is the value of total time that we already calculated, right? So which formula will help you? Try to find out very simple one, the simplest one, the easiest one that will help you.
The one that you taught us today, the U equals
Mm,
U cos.
but in that formula, we are not able to find the distance, right? Just think about the horizontal distance, that which
Oh,
cos.
S equals speed multiplied by time.
Yes. So the very simplest formula, very simple one, is speed multiplied by time. So we are not going to take a very long equation because we know time is already calculated in detail. So R is equals to U cos theta multiplied by time divided by G. Okay. So you can easily find out the value and you can see that u multiply, so it will be u square. But we need to use another trigonometric identity, just like the formula that we use in previous derivation somewhere. So basically when we multiply the equation, so you will get 2 u square cos theta sin theta, right? So if we just ignore u square and if we consider 2 cos theta sin theta, so it will actually equals to sine 2 theta.
Okay.
Okay. So this is the trigonometric identity. So we are not going to discuss about the derivation of this identity, and there is no use and there is no concept to explain this one in your answer. So there, this is only the direct identity that we are going to use in our formula. So your final answer will be equals to R is equals to, first I just arrange the equation. It will be equals to, sorry, 2 is no more there. Okay. Any confusion?
No. So like from this equation, I'm get like when you like solve it in the calculator, it'll give me like two answers, which are gonna be the range.
Yes. If you just find out the direct, because it depends upon the question. Sometimes they give you the direct question. Sometimes it
Mhm.
like we need to solve something else. Then sometimes we need to find out the value of time. Then they ask the range. So if you just write all the things like angle, initial speed, value of G, so you will definitely get the value of range, right?
All right.
So this is the concept of range, total time to flight, and the maximum height reached by uh, the body. Okay.
Okay.
And there are some important things related to the, let's write the final formula. So basically your final formula is, so previously we discussed three different equation. Those are completely new, and these three formulas are now completely different and completely new. So basically whatever they ask you about the question or anything they will ask related to the projectile, so you may just take the value, take the reference, because During the derivations, you are also getting the information that how to start or how to drive the concept from the basics, right? Because we start from the very basic thing and then we drive these formulas, right?
Yeah.
Any confusion?
No.
Okay. So let's suppose if we consider one question from the past paper, because last time I think we solved which year paper, I don't remember. Okay, let's choose first the latest one. Okay, first find in the March, because we usually start with March 22. Our main priority with the March. Yes, we find the question of projectile. Okay, so first observe the question, observe the values. Then we will start the solution of this question. Okay, got some knowledge from the question?
Wait, I'm still like
Okay,
processing it.
okay.
So basically what we're seeing is projectile motion, but
Yes,
like the second half
half.
of the graph
Yes,
actually.
yes,
And it's not the first half because the first half is going to be positive and the second half is like negative, right? Uh,
yes. Okay, let's see the first part, right? For what they are asking, because usually they start with something different, then they comes to the main point. So explain briefly why the horizontal component of the velocity of the droplet of water remains constant as it moves from P to Q.
um, why it remains constant?
Yes, because
Because
during the explanation we discussed that we take air resistance negligible. It means resultant force on the droplet of the water will be zero, right? Because we
right.
know that once the body is moving with constant velocity, so either all forces are balanced or either
So
there
the
is no force acting on
force
the body.
so the force in horizontal direction is zero. That's like the answer.
Yes, yes.
So then for the time, we know speed equals to distance over time. So time equals to distance over speed. And the distance was 3.5 meters. So you're going to do 3.5 divided by 6.6, which was the speed. And you get 0.53 seconds.
Okay, so you already solved the question in the verbal. So basically we have to use the value s equals to vt, and time distance is 3.5, and speed 6.6. Speed is also given, and what will be the value of time that we need to find out. So that is very simple. 3.5 divided by 6.6. So you will get the value of time. Okay. You
Okay.
get the same value, right? Because answer is already there. Calculate the height. Okay, you may take the reference from the diagram again.
Okay. How do we do this? Uh, we have to use one of the equations of motion, right?
First of all, just take the initial point. We are taking downward motion, right? And during
Yeah.
downward motion, what will be the initial velocity?
6.6.
6.6 or 0,
Oh, zero.
right?
Because it's
Yes,
acceleration
yes.
is.
So at initial, we have initial velocity 0. So we have to use that formula in which initial velocity is always there, right? So we only need to consider initial velocity. So now you got the equation. Which equation will help us to find out the value?
S equals ut plus
Half
half
g square,
at square.
at square, or we just replace a with g, right? So once
Okay,
you got the initial value, so then it will be easy for you to find out the final answer, right?
okay,
So time is given, right? And value of g is positive 9.8 and t is already calculated.
okay. So it's gonna be 0.5
Yes.
multiplied by 9.81 multiplied by 0.53 square. And since 0 is multiplying with the t, the initial speed is 0, so it's gonna be only half multiplied by 9.81 multiplied by 0.53 squared.
Yes. So we will get 1.4
Okay.
because this part completely equals to 0. So don't need to multiply that or write that. So we will get the height. So till now we are having very easy question for 4 mark. Let's see in the next part what they are asking. So you got the question what they are asking?
Yes.
Okay.
So, displacement
So whether
is
the displacement of droplet is less, more than, or the same as the distance, okay. So if they are
so this
asking about displacement, so what we need to do?
we have to look at the graph, the line. Okay, so what we can see is that displacement is gonna be like a straight line.
Yes,
So the distance along the path of like displacement would be less.
yes, simple, right?
Distance is shorter.
Yes. So displacement will be shorter or distance?
Um, displacement is shorter, but like in the graph when we like measure it, the line, it will be shorter than the distance. But displacement for the question, because
Yes. Just give me 1 minute for the
okay.
the final part. You need to calculate the magnitude of the displacement.
Okay, so what we're gonna do is we're gonna wait. How do we do that?
Okay, so you know that now we are going to
Wait, I
calculate.
got it. I have it. I have it. I know how to solve this.
Okay.
Okay, so what we're trying to find is the hypotenuse, and we know from Pythagoras' theorem that h squared equals to p squared plus
Mm,
uh b squared, right? The perpendicular and the base. So we're gonna do is 3.5 squared. plus 1.4, right? 1.4 squared. And then we're going to take the square root of that.
Very good. So you just need to solve in the same way. Right angle triangle concept. Okay, so you will get your final answer. Very simple, right? So very good.
Right.
Right concept. Okay, so this is the answer for your question. Because this concept is very easy, so question is for 7 marks. But you observe that you will get easy 7 marks this time if you are going to solve this paper at this particular time. And we already solved question number 1 in previous class, right? And one more thing,
Mhm.
I also make a drive link for your whole notes and the solutions that we are doing in our class, and I will
Yeah.
update that link in the group. So whatever you need to find, so you may find out in each and every particular folder on your drive, right?
Okay, thank you.
So we already solved this one, so you will find that one in the section of chapter 1 theory section, right?
Okay.
And this question you will find in theory section of second chapter, that is kinematics. And you know that we also solve this question in waves. So it means we only left out with question number 4 and question number 3 from this paper, right? Otherwise we completed all other parts of this paper. Seven, we left out with 2 questions, right? So it means we have to focus on those remaining 3 or 4 chapters. So that will make our remaining 2 questions. So it means we are able to solve 5 questions out of 7 from your paper, right?
Yes. So we
So
just need to do 2 more then.
yes, because those are like elastic deformation. Because when we are solving elastic deformation, so work energy combines with that. So that is the concept. Okay.